So if you want like I'm going to put the attendance back up. But if you want like a thing of things to study or a thing of things to remember, it will be today's lecture. And if you have any questions at any point, you can just raise your hand. And if I'm not looking at you, you can just yell my name and you'll have a question. So Java is object-oriented, as we've been talking about. The three shapes that we must always remember are this rectangle, this oval, and then these triangles here. So who can tell me what goes in this box right here? What are the rectangles? What was that? Last other one. Interface. Usually represented by a, wait, am I getting this wrong? Oh, or maybe see, this is why I'm going over this again, because I get confused sometimes. All right, we're gonna go to carbon. I think you're right. I think interface is definitely at the top, but I think it's an oval. I don't think it's a rectangle. All right. Okay, we're gonna skip ahead a couple slides because I know that there's a diagram in here, but don't look if you don't want to get. Okay. No spoilers, but that's slide 2 of this Thursday's lecture. So. Okay. That was a test and you guys passed. Okay. I drew it wrong again. Okay. Who can tell me what's in these circles? Ovals. It's not class. It's not objects. Interface. Okay. Hopefully I didn't just confuse you guys, but these green circles are always going to be interfaces. And what is their purpose in Java? Or what do they do? What do they contain? Yeah. Exactly. It describes functionality for a class. So it says, hey, let's say that we wanted to make a calculator class. Here is all the things that a calculator class ought to be able to do. It ought to be able to add things. It ought to be able to subtract things. It ought to be able to multiply things. I'm not going to describe how to actually do that. That is up to you, the next one here, to actually come up with implementations and actually figure out how to do that. But I'm just going to provide you with contracts for how to do that. That gets us into the next thing. What is contained within these blue rectangles? Classes. And what is the purpose of a class? It actually implements the functionality. And when we have a class, which describes functionality for an interface, and we're drawing these charts like we do, what is the term that goes right here? What do we say about the class? We say that the class blanks the interface. Other one. Implements. Yeah. So when we say that a certain class implements an interface, we're saying that it's going to provide all of the functionality for that interface in actual code. So it's going to provide the code to actually add, subtract, multiply, divide for your calculator app. There's another one that's not shown up here, which is extends. Can anybody tell me what extends does? Going once. Going twice. Yeah.
Like inheriting all like the methods of another class.
Yeah, exactly. It just takes everything that is in the class or the interface that it's extending and basically just appends it onto whatever class it currently is. It's a way of siphoning out code to a general purpose thing so that you don't have to have 100 different versions of 3 method contracts. What is the interface? Does anybody remember that all OSU CSE components derive from? It starts with an S. Standard. And that comes with pre-built-in methods. I'm going to withdraw the first. We're play like a hangman type thing. That comes with three methods that all OSU CSE components derive from, and they are what? Does anybody know? Starts with C. Yeah. Clear? Which does what? Zero or yeah, or original value. Takes whatever the OSU CSE component and says, hey, go back to whatever your initial value was. Okay, cool. What is the next one? Two words. We're doing trades. Starts with N and then I. New instance. Wait, who said that? I'm going to click on you and tell you tell me. Who said that? What does new instance do? Call a friend? Yeah. Returns a new object of the same object type that you call it on. And this is important because we can have multiple classes implement the same interface. So multiple classes that have different functionality, but provide the same purpose. So maybe you have a calculator app that calculates everything in terms of integers, and I have a calculator app that does everything in terms of natural number. It might have the same exact functionality. However, the way that we go about accomplishing that is different. And so you cannot mix class types. So if you have say a calc1, which implements the interface, and a calc2, which implements the interface, and you're writing a method, and you need to know which implementation you're using, it's important to use new instance because it will always return to you the same type. So if you call it on a calc2, it will return a calc2. If you call it on a calc1, it will return a calc1. Okay, last one. TF. Transfer from. And what does transfer from do?
What is the value? And then the original value will be 0.
Yeah, so it transfers whatever value is in one object to the other value, and then resets that other value. So if you have a natural number 8, and then you call natural number dot transfer from on a natural number that's like 16, you transfer that value 16 into the original natural number, and then that second one that you call transfer from on gets reset to an initial value. Okay, those are the three methods that are in every single OSU CSE class. And the reason that that is the case is because every interface which describes the functionality for an OSU CSE component, say natural number or stack or queue, extends the standard interface. So above this all is one superclass that everything inherits from, which has these three methods. So any OSU CSE component you have is able to use these methods. Now, clear, new instance, and transfer from, how the methodology actually happens in order to clear, create a new instance, or transfer from, is described in the class. So a class must implement every single function or method that is described in the interface, as well as every single function or method that is described in interfaces that it extends. So let's say interface had 5 methods, or like 4 methods for add, subtract, multiply, and divide. But then it also extends standard, which has clear, new instance, and transfer from. This class must implement a total of 8 methods. Sorry, 7 methods. Sorry. Okay, we good on that? Cool. Okay, now we are ready to go to our final layer in this game, which is these equilateral triangles, although let's pretend it's equilateral. And what do these represent?
Objects?
Objects. Correct. Objects are always what type? Primitive or reference? Who said it? Reference. Objects are always reference types, which means that the actual value of that object is not stored directly where the variable name is stored. However, it is a pointer which stores the actual, is a pointer to a location in memory which stores the actual value. So we always draw reference types with these equilateral triangles, which represent objects that point towards some location. So if this was the natural number, it would point towards the actual location of the natural number. We distinguish between the two by saying that this is the reference location, So where the reference is stored, and then we say that this is the object location or the object value. And when we're talking about code, when we're talking about the value of reference types, we usually are talking about the object type and not the reference type, because the reference type is not that interesting. It's the actual object that we care about. Okay. That's like pretty much a crash course on object-oriented programming as it pertains to this class. Another thing, classes can extend other classes. So a good example of this is perchance a car class. A car class might inherit a bunch of methods from a car interface, which describes functionality that ought to be achieved by any such car, such as driving, reversing, steering, putting on your blinker, even though most people don't use that functionality. And then the car must implement that. So how that actually happens is up to the car, but you can have a class that extends another class and say that this car is like a Tesla. Since it extends the car class, it should have all of the same functionality as a car. However, it might also have additional methods that normal cars do not have. So it might have a method, a void method that's just turn on self-driving mode. A normal car wouldn't be able to do that, but since we're making a child of the car class, you're allowed to add additional methods. Now, another thing of note here, I don't think we've gotten into this yet, but it's important, so I'm just going to prime it here. Say the car has a drive method. If you then extend that car class and you want to change the functionality of how the drive method works on a Tesla, what you can do is you can override this drive method by adding override annotation. And you can provide a new implementation of the drive method for just Teslas. So it will overwrite the implementation of the car method drive that you've implemented because you're a class, and provide it with a new functionality. We'll get into how that works, but that's just a teaser. It's an end credit scene. It's a mid credit scene. Okay, I think that's everything in terms of object-oriented stuff. If you can understand that stuff, you will be on the right path. A little bit of a cheat sheet. Between classes and interfaces, classes can only implement interfaces. So classes cannot extend interfaces, but classes can extend classes and interfaces can extend interfaces. So
One more time.
Yeah, I'll write it down. Okay. Classes can only implement interfaces. And classes can extend other classes, interfaces, and extend other interfaces. But a class cannot extend, I don't know how to do like a cannot, do like that, cannot extend interface. If you wanted to go about doing something like this, you would just have a class implement an interface which extends another interface, or you would have a class extend another class which implements the interface. So here's your cheat sheet here. You will never have a class that extends an interface. Okay, that's object-oriented programming as it pertains to this class. I'm sure there's other stuff as well. Any questions? Awesome. I'll give it like 30 seconds and then I will erase and the knowledge will be gone forever. Okay. Next up, we're going to talk about, again, reference types and how they work in terms of passing values. And we're going to talk about aliases. So when you have two reference types, or when you're working with reference types, remember that there are two types of reference types. There are what are known as mutable reference types, and there are what are known as immutable reference types. Who can tell me the difference between the two?
Immutable can't be changed. Immutable can be changed.
Yes. So the object value of a mutable type can be changed. However, with an immutable reference type, the object value cannot be changed. I'll say cannot be changed by methods called on that object type. So it cannot be changed by instance methods. Because obviously you could set a XML tree equal to a new XML tree and provide it a new link, and that would change the XML tree, but that's cheating. Object value can be changed by instance methods. So if you look at the API for a XML tree, you will only find methods which provide you information. .label, .isTag, .number of children. You will not find a method that allows you to add a new child or remove a child or change the value of some tag, because XML trees are immutable. Once they are defined, their object value cannot change. Contrast this to natural number, which has a bunch of methods that allow you to change the object type. Increment, decrement, multiply by 10, divide by 10. All of these methods allow you to actually modify the value of the object type. Okay, reference types, again, are always defined by this equilateral triangle, the most important symbol in this class. How you would draw it is that you have this box, and then I'll draw this again because it's important. This is the reference value of the object, and then this is the object value. So the reference value is basically a location which points towards where the object value is stored in memory. And then the object value is stored what you actually want. So say it's a number, you can store that there. Okay. The big difference between reference types and primitive types is, again, how they're stored in memory. So compare this to an integer, which is a primitive type. Let's say that this is variable x. Variable x as an integer would just be stored directly in memory. Is how they are passed to two methods. And I'm going to say this again, and 90% of you are not going to follow this, but when you get a question that asks you to reason about passing parameters into methods with reference types or primitive types, draw a picture. 99% of you won't do that, but that's okay. You'll get it wrong. Read my theory. But here's an example of what that might look like. Foo is a method, a good old method that we use quite often, which takes a natural number A, a natural number B, and a natural number C. And what does it do? It says A dot increment. It says B dot clear. And it says C dot decrement. Probably one of the most interesting methods that has ever been written. This is what the creator of Java was intending. And then there is a second version of that method called foo2, which takes in an integer A, I means integer, an integer B, and an integer C. And what it does is it says, hey, A plus plus, says B equals 0. Oh my gosh. And it says C minus minus. So the functionality of this is technically the same, but let's go through an example of what this might look like. So say that you have a natural number x, which is a reference type pointing to the natural number 4. You have a natural number y, reference type points to the natural number 5. And you have a natural number, wait for it, z, which points towards a natural number, wait for it, 6. Then let's say that you have an integer stored directly in memory as 4, the integer y stored directly in memory as y, and then you have an integer z stored directly in memory as 6. And then we make two function calls, which I'm going to do over here because I'm running out of space. We call foo xyz, and then we call foo xyz. Okay, wait. XYZ, but we're passing the integers. Foo2 XYZ. Anyway, it's different, nothing for a reason. Here's what happens. So when we go into a method call, remember, we suspend the thread of execution of the main method, or whatever method we're in. We're saying, hey, it's foo time. And we create 3 new variables because they're needed for the code. We say natural number A, so we need a natural number A. What is that? Well, it is a reference type, and so we point A towards X. We say A is representative of this natural number X. We set the reference types essentially equal to each other. Then we have natural number B. We're saying that that goes into Y. And then we have natural number C, which points to C. Okay, I know I said to draw pictures because it's useful, and then I drew the most hideous picture of all, but you could imagine that there was more space and I drew them in a way that is kind of ugly. Okay. Anyways, here's what happens next. I'm gonna go here. Okay. We call a.increment. What happens is Java goes towards A and it says, A is a reference type. I need to follow the map. So it says, okay, over here, go over here. Okay, now I'm at X. X also has another location. Okay, go to here. And it says, okay, cool. I'm at an object type. I can now conduct the code that I need to conduct. It says increment. So 4 becomes 5. Then we go to B. B says, okay, it's a reference type. I can't clear a reference type, so I go to this. This is Y. Y is a reference type. I have to go to the value. Okay, now I'm at an object value. I can call clear. Awesome. 0. And then C follows the treasure map to Z, which goes to 6, which calls decrement 5. So the values of the actual variables X, Y, and Z, which are defined outside of the scope of the method, have now changed. Because instead of just passing by value, we have passed the references to A, B, and C. So anything that we do to modify those values will modify the original values. Contrast this, a lot easier. This picture is actually going to be a lot better. To A, B, and C, where we just copy the values directly into these variables. Don't copy the references. And then we say A++, so A becomes 5. Shock goes across the floor. And then we say A++, so A becomes 5. We say B equals 0, cool, B is 0, C minus minus, C is 5. Method ends, and so Java says, you variables A, B, and C, you have been good to me, but you must die. It kills A, B, and C. But after the method function has concluded X, Y, and Z retain their original values. So 2 methods which look to appear to do the same thing, but since we are passing reference types as opposed to object types, do different things. One is passed by value, and one is passed by reference. Questions on that? Yeah.
Are we supposed to write it like in a line?
Right, in a line. You mean like drawing the pictures?
No, like after you pump,
Wait, sorry.
like at the end.
Oh. After I went to the code. How I like write them in a line?
Like at the end, like how you supposed to write it?
Oh, it would depend on the question. So let's say that the question said, what would be printed out by out.println A, out.println B, out.println C. In this case, it would be 505 because the values were changed. But in that case, if you did out.println A, out.println B, out.println C, sorry, X, Y, and Z, as opposed to A, B, and C. X, Y, and Z are the variables before we pass them into the method. There's two versions. There's A, B, and C, which are the formal parameters in the methods, and then there's X, Y, and Z, which are, say, like in a main method. And after the function executes, X, Y, and Z are going to be 5, 0, and 5 in terms of reference types, but they'll be 4, 5, and 6 in terms of primitive types. Passed by values. I don't think an example would get this confusing, but I assume there's eventually going to be a question that asks you and for tests whether or not you can understand the difference between the two. Okay. Questions on that? Okay, another thing that's important to note is the idea of passing duplicates. So we talked about this at some point. I don't remember time is a flat circle. But if instead of saying foo x, y, z, we instead said foo x, 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 or yeah, instead of saying foo x, y, z, we did like z, 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 or something like that. We did the same thing for foo 2. What happens in this case is different, again, depending on whether or not you're using reference or reference or primitive type. In the primitive type case, let's say that z is just the value of 4. When we call foo2, A, B, and C again are just copied into the boxes over here. The values of A, B, and C, so 4, 4, 4, and then the program carries out as it would. 5, 0, 3. Again, at the end of the code, after the method has concluded, A, B, and C go away because they're only within the scope of this method. And Z simply just remains as 4. However, when you're passing by reference, what happens is Z, a reference type, points to the object value 4, and then A, B, and C are all reference types which point towards Z. What's going to happen is A.increment is going to follow the map to the object location. It's 5. B.clear is going to clear the value. And then C.decrement is going to cause the program to crash because natural numbers cannot be negative. But pretend that this is increment. C.increment now is going to go to the object value and make it 1. So you're modifying the same object value with all 3 of those calls because all 3 of those variables are references to the Z variable. This is known as aliasing, and it's very harmful. Aliases are essentially when you have 2 variables or 2 reference types which point towards the same object type. So we have our natural number x, which points to the object value 7. If we then wrote the code x equals 7 or x equals y, where y was another natural number, what this does is it sets both reference types equal to the same object type. And this is extremely harmful because as with passing the same value into multiple reference types, any operation or instance method that you call on either of these natural numbers will modify the same object value. So y.increment will increment it, x.increment it, x.increment will increment it. And this is not good because typically you want to separate out your variables and your values so that you don't get confused. That's why, yeah.
Super quick clarifying question. So foo1 would be passed by reference and foo2 is passed by value?
Yes.
Okay, cool.
And it all just depends on whether or not you're passing reference types versus primitive types. You could have a foo3, which takes in 2 natural numbers and 2 integers, and it would work how we've done it in this example, where the reference types would be passed by reference, and you would point the formal parameters to the variables that are passed in, and then the primitive types would work as the primitive types have worked, where you just copy the value. So you can also mix types as well. Okay, that's alias. Yes.
Is there a situation where you would ever use an alias on purpose?
That's a good question. I'm 100% sure that there is. Not in this class. You would never intentionally want to create an alias in this class. I'm sure there are smart ways to use them that don't mess with things, but I don't know that. Okay, any other questions on, what is that, reference types versus object types? Or I guess it's the same thing, reference types versus primitive types. And then examples of primitive types include ints, cars, doubles, booleans. Examples of mutable reference types include like natural number and stack and queue, which we'll get into. Examples of immutable reference types are XML trees, strings, that, and the like. Okay. All right. Now it's time to go to our final topic for today's catch-up session, which is recursion. The most fun topic is taught in this class. At a base level, or at a bird's eye view, looking down upon this classroom, upon Dries Labs, what is a recursive method? This was your attendance question on Friday, so I hope, yeah, I'm gonna get that call. So perfect. A recursive method, spell it right, is one which calls itself. So this means that somewhere contained within the code for a recursive method, it will have a function call to the method that it is in. It's not simply something like, let's say you have foo1, which takes in 2 integers, and then you call foo2, which takes in 2 natural numbers. So it has like same methodology. It's the same exact method that you're already in. And typically, when we're writing recursive methods, it is to conduct elegant solutions to problems that might be able to be done iteratively, but are more fun to write recursively, I guess. There are 3 things that you need to include in order to have a recursive method function properly. They are the 3 rules of recursive methods. And this is not an OSU CSE thing, this is a me thing, so it's trademark. The first is that you must make the problem smaller. And this goes back to the free lunch example. We talked about it on Thursday. But you want to reason about recursive methods as if you have a magical class called free lunch that will do the exact thing that you're intending the method to do, but only on a smaller case. You can do that, but you first must make the problem smaller. So in the case of the reverse string method, we technically had a method that would reverse a string, but it had to be a smaller version of string. And the reason we have to make the problem smaller is because eventually something must give and we must stop recursively calling ourselves. Because you can imagine if a method calls itself, which calls itself, which calls itself, which calls itself, and there's no way that you're making the things that you're passing in smaller, you will have basically an infinite loop. It's what's known as a Stack Overflow answer. Stack Overflow, also a very good website for finding solutions to problems, but we'll get into how it works later. But essentially, Java treats recursive methods as their own separate little bits of code, and it puts them on like a little stack. It's called the stack trace. And if you have too many of them, like a tower, will topple over and you'll get a Stack Overflow error. So that's why you must make the problem smaller. Now, making the problem smaller is not the only thing that you must do in order to make sure that the method eventually stops calling itself, but you need something known as a base case. A base case is a part or a destination that you get to, in which case you cannot further simplify the problem. It's the case where making the problem smaller would be impossible. So you can think a base case as an empty string or potentially an empty natural number. You cannot call increment, or you cannot call multiply by 10 or divide by 10 on an empty integer if you're trying to implement like an increment or a decrement number. Decrement method, it might be, say, those are the 2 main ones. Usually we only do recursive methods on strings and natural numbers. But it is the kind of a signal to your recursive method that, hey, we are done recursively calling the method. you can go back out and complete the other steps of the recursive. And then finally, the third one is the easiest one, is you need a recursive call. So you need somewhere in the method there to be a call to a method or call to the method that you're already in. If you're writing a recursive method for this class or for any class or in the future, you must ask yourselves these three questions. Have I made the problem smaller each time that I call the recursive call? And do I eventually have a base case? If you miss one of these, your code will not work. So you must have all three of them. Okay. Let's go through pseudocode. Unless anybody has any questions, we'll go through a bit of an example. Cool, example time. And then I'll let you guys think. Let's pretend that we're writing a method which is going to determine whether or not a string that is passed into a method or a function is a what's it called when it's like the same thing forwards and backwards? What is it?
Palindrome?
Palindrome. Yes. Okay. We're drawing an is palindrome method. So something like Hannah, my sister's name, is a palindrome. As long as you have it lowercase. Something like Taco Cat is a palindrome. Because Taco Cat is the same forwards and backwards. Something like my name, Stephen, is not a palindrome. How would we go about writing the pseudocode? Pseudocode is basically just not writing actual code, but it's like writing in English what you would do. It's a good way to plan out what you're going to write before you start writing actual code. Just a tip or a tool of the trade there. Okay, so if we wanted to make a recursive method which determined whether or not a string was a palindrome, here is the method that I would use. If we know that given a string, say Hannah, if we know that there is a way to tell whether the string contained between the first and last characters is a palindrome, all we have to do to determine whether or not the entire string is a palindrome is test whether the first and last character are a palindrome. This works with any palindrome. So if we have a way to test whether Anna, A-N-N-A, is a palindrome, then all we need to do to check whether or not a palindrome or an entire string is a palindrome is by checking the first and last characters. So how you might write a recursive method for this would be something like first car, check first and last characters. See if they're equal. Would actually be step 2. The base case in this case would be whether or not the string has a length of less than 2. Because a fun thing about palindromes is, let's say my sister wrote her name weird and wrote it as Hannah, H-A-N-A-H. First and last character you cut off. This is still a palindrome, even though it has 3 characters, because every single letter is a palindrome, because N forwards and backwards is the same. So as soon as we get to a string which is less than 2, we can break. So our base case here, we can stop when the string length is less than 2. Okay. So we check the first and last characters to see if they're equal. If they are, we set some return value equal to true. Now, next thing we have to do is we have to, else we just return false. Or set our ret value equal to false. Next thing that we have to do is we have to check the smaller version of the string and make sure that that's a palindrome. So after this, we would do something like chop off first and last character. And then check if that is a palindrome. We're going to use the free lunch method here because it's the way that they like to teach it. You can call free lunch dot is palindrome. So we have made our problem smaller by chopping off the first and last character. We have our base case, which is to stop when the length of the string is less than 2. Finally, we have not a recursive call, but a call to free lunch, which, if you remember, there is no free lunch. So we simply call is palindrome on our string. The magic of Boolean methods, though, is we have to make sure that retval, we're going to set retval equal to retval and is palindrome. Because in order for it to be true, both the first and last character of this string, yes, must be the same, but first value of this string must be the same, and the first and last value of this string must be the same. And what setting retval equal to retval plus is palindrome will do is if at any point, let's say that it is Hannah, but she has a Ina, it's a foreign, and it gets to this point, I and A are not equal to each other, and so retval will be false, which will get passed up to the recursive call of is palindrome. This will be false, so false and true equals false, which will get passed up to this recursive call, which false and true will be false. And so finally, you can return ret. That is pseudocode, not actual Java code, for how I would write a recursive is palindrome method. And again, it has our 3 rules of recursive methods. We've made the problem smaller by chopping off the first and last character and just focusing on the inner characters. We have our base case, which is when the string is less than 2. And then we have our recursive call. The recursive call, we are calling on the string which is smaller. If this is still confusing, don't worry, you get a lot of practice with writing recursive methods over the next coming weeks. And I also have a bunch of extra practice methods that I will be giving you guys before the next exam. So don't worry, you'll have a lot of practice. But if you can remember those 3 things, make problem smaller, base case, and recursive call, you'll be doing okay. Any questions? Yeah.
Clarify, under chop off first plus last char, it says retval equals parentheses char.
No, it's written quite poorly. Retval equals retval plus it is palindrome.
Okay.
Because in order for it to be a palindrome, first and last characters must be equal to each other, and the smaller version of is palindrome would also be a palindrome.
Okay.
And you would pass in smaller version.
I think I get it.
Cool. And everybody's packing up, which means that I guess we're getting out of class early, which we are, because I don't have anything else to talk about, unless you have any questions. So yes. I love the zipping of the backpacks. You guys are like sharks. You can smell when I'm done the lecture.